Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Backups play a vital role in IT operations by safeguarding data against unexpected loss from hardware failure, malware infection, human error, or environmental disaster. A comprehensive backup strategy includes more than just copies of user files. It involves full system images, recovery plans, and documented procedures for restoring services. The A+ certification emphasizes familiarity with backup types, scheduling practices, rotation strategies, and validation techniques. Understanding how to protect and recover data is not only crucial for passing the exam, but also for maintaining business continuity in real-world IT environments. A full backup creates a complete copy of all selected data, regardless of whether the files have changed since the last backup. This method takes the longest to complete and requires the most storage space, but it provides the most comprehensive snapshot of the data at that moment. Full backups are typically used as the foundation for other types of backups and are performed on a regular schedule to serve as a reliable recovery point. Because they include everything, they are often the first step in recovery after major incidents. Incremental backups only store data that has changed since the last backup, whether that last backup was full or incremental. This method reduces storage needs and minimizes backup time, making it ideal for daily or even hourly protection in active environments. However, restoring from incremental backups can be more time-consuming because the full backup must be restored first, followed by every incremental backup taken since. If any link in that chain is missing or corrupted, the recovery process may fail, highlighting the importance of reliable backup software and monitoring. Differential backups offer a middle ground between full and incremental strategies. A differential backup stores all changes made since the last full backup, regardless of any intervening incremental backups. This means that while differential backups grow in size each day until the next full backup, they allow faster restores because only the full backup and the latest differential backup are required. This method simplifies recovery while maintaining relatively short backup windows, making it a popular choice in many organizational settings. The 3-2-1 backup strategy is a widely accepted standard for data protection and is tested on the A+ exam. This approach involves keeping 3 total copies of data, 1 primary and 2 backups. 2 of those copies should be stored on different types of local media, such as a hard drive and a network-attached storage device. The 3rd copy should be kept off-site, either in a separate physical location or in the cloud. This structure ensures that data is resilient against hardware failure, accidental deletion, and environmental disasters. Grandfather-father-son, or GFS, is a rotation strategy used to manage backup frequency and media usage. In this model, daily backups are referred to as sons, weekly backups as fathers, and monthly backups as grandfathers. This structure allows organizations to retain historical data while reducing wear on backup media. GFS also simplifies long-term data retention by allowing older backups to be archived on more durable or off-site storage. This method supports compliance requirements and enables historical data analysis if needed. Snapshot and image-based backups capture the entire system state, including operating system, configurations, and application data. These methods allow for rapid full system recovery, especially in environments using virtualization or large-scale server deployments. Unlike file-based backups, which require reinstallation and reconfiguration of the system, image-based restores can bring a machine back to a specific point in time with all settings intact. This makes snapshots particularly useful for disaster recovery and lab environments. Consider a situation where a ransomware attack encrypts all user files on a workstation. The organization responds by wiping the system and restoring the full operating environment from a weekly image backup. To recover the most recent user data, the technician then applies the latest incremental backup. This layered recovery approach ensures both system functionality and user data are restored accurately. Confirmation is performed using backup logs, and the entire process is documented for audit purposes. Cloud-based backup solutions store data, with third-party providers using internet-based services. These platforms offer scalable storage, geographic redundancy, and high availability without the need for on-site infrastructure. Cloud backups are ideal for organizations with remote workers, mobile devices, or limited internal resources. However, it's important to ensure that backup data is encrypted, access is tightly controlled, and retention settings align with company policies. The A+ exam includes cloud backup security considerations as part of its core content. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Local backup storage options include external hard drives, network-attached storage devices, and dedicated backup servers located within the organization's premises. These solutions offer faster data access compared to remote or cloud options, which makes them ideal for quick restores and routine backups. However, local backups are vulnerable to physical damage from fire, flooding, or theft. For this reason, many organizations combine local backups with off-site or cloud-based backups to create a more resilient and flexible recovery architecture. Backup scheduling and automation help ensure that backups are performed regularly and without relying on manual steps. Organizations can schedule backups to run at daily, weekly, or monthly intervals, depending on the sensitivity of the data and the rate of change. Automation can be handled using scripts, backup software, or integrated features within operating systems and cloud platforms. Most tools also include logging functions to record backup results. These logs are critical for verifying success and troubleshooting failures. Backup verification and testing are essential for ensuring that backed up data can actually be restored. Simply having a backup is not enough. Technicians must review logs to confirm that the backup completed without errors and periodically conduct test restores to verify file integrity. Full restore tests simulate the recovery process and help identify gaps in documentation or configuration. Testing provides assurance that the recovery plan will work when needed and eliminates false confidence in unreliable backups. Off-site storage adds an important layer of protection by moving copies of critical data away from the primary location. This guards against disasters that affect an entire facility, such as fires or floods. Off-site storage can be achieved through physical transport of backup media or through automated cloud synchronization. Regardless of method, off-site storage must comply with privacy and retention policies, especially in regulated industries. Encryption and secure handling procedures are vital to maintaining confidentiality. Restoring from a backup requires a systematic approach. First, the technician must identify which files, folders, or systems need to be restored and why. Next, they choose the correct restore point or version based on timestamps or backup logs. Once restored, file integrity should be verified by opening documents, launching applications, or checking system performance. In larger environments, restore operations may include cross-checking with users or performing checksum validation to ensure accuracy. Versioning and file history tools store multiple versions of a file, allowing users or technicians to roll back to an earlier version in case of accidental changes or corruption. These tools are especially useful for documents and project files that change frequently. Windows File History, for example, allows users to browse older versions of files by date. Cloud storage platforms such as OneDrive or Google Drive also offer versioning features. These options reduce the need for full restores when only a single file needs correction. Retention policies define how long backups are kept before being deleted or overwritten. These policies vary depending on business requirements, compliance obligations, and storage limitations. Shorter retention reduces storage cost but limits historical recovery. Longer retention supports forensic analysis, audit readiness, and recovery of long-deleted files. Retention settings must be carefully configured in both on-premises and cloud solutions to meet organizational and legal standards. Security is a fundamental requirement for all backup systems. Backup data must be encrypted during storage and transmission to prevent unauthorized access. Strong passwords or encryption keys should be used to protect access to backup files and systems. Physical backup media, such as tapes or external drives, must be stored in locked cabinets or secure off-site facilities. Any compromise of backup data could result in the same level of exposure as losing the original files, making backup security a central concern on the A+ exam. The risks of not backing up data are significant and multifaceted. Organizations that fail to implement proper backup procedures are vulnerable to data loss from hardware failure, cyber attacks, or user error. Downtime caused by missing data can lead to lost revenue, missed deadlines, and damage to customer trust. The cost of recovery increases dramatically when no backups exist, and in some cases, data may be permanently lost. In regulated industries, failing to back up data properly may result in legal penalties or loss of certification. To conclude, technicians must be familiar with a wide range of backup methods and strategies, including full, incremental, and differential backups, as well as policies like the 3-2-1 rule and GFS rotation. Backups should be scheduled, tested, and secured consistently to ensure data is available when needed. This topic is heavily featured on the A+ exam and forms a cornerstone of real-world IT responsibility. Mastering backup procedures prepares technicians to maintain continuity, respond to incidents, and support reliable service delivery. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.